Hi there everyone, and welcome back to another lesson from the UCCS Engineering Exploration Workshop. In today's lesson, we'll be talking about electronic component innovation, as well as how LEDs work. First, let's talk about how LEDs work. We have used LEDs in several projects now, but we have not really talked about how they work. LEDs, or light-emitting diodes, are a type of semiconductor. In simple terms, an LED is made up of P-type semiconductor material containing positively charged carriers called holes, and N-type semiconductor material filled with electrons. When a current is placed across the diode, it forces the electrons to move to the positive holes and the holes to move towards the electrons. The holes exist at a lower energy level than the electrons, so the electrons lose energy so they can join with the hole, and this energy is given off in the form of photons, or in other words, light. It's a great way to make a light source, and LEDs are used in everything. But as engineers, we always look for ways to improve inventions. In our case, it's the LEDs. In this circuit today, we'll be using the RGB LED to make the circuit. Here above is the diagram of it. It's basically several LEDs all combined into one small package. Here's one that I made at my house, just to show you all what it looks like in a more crude form. The point of the circuit right here is to show you that as engineers, you can make inventions, but a great engineer never stops finding ways to try and improve inventions. So, here's the circuit diagram for circuit 1D. Feel free to pause the video to build the circuit or build along with me in the next clip. The circuit actually uses the same photoresistor configuration from circuit 1C, so that can be left on while building. Okay, first thing, let's grab the RGB LED on the breadboard. The longest leg on it is the ground, so make sure to keep track of where it is. On all the shorter legs, we will put a 330 ohm resistor to limit the current to the LEDs on the inside. Then, we will use a black wire to connect the LED ground pin to the breadboard ground rail. Next, we will connect a red wire from the red pin of the RGB LED to pin 9 on the Sparkfun Arduino board. Then, we will connect a green wire from pin 10 on the Sparkfun Arduino board to the green pin on the RGB LED. Finally, we will connect a blue wire from pin 11 on the Sparkfun Arduino board to the blue pin on the RGB LED. And now, our RGB LED is all set up. So, let's go set up the potentiometer. We need to place it onto the breadboard, and then connect the far right pin with a red wire to the power rail. And then we need to connect the far left pin with a black wire to the ground rail. And then the middle pin will be connected to the pin A1 on the Sparkfun Arduino board with a blue wire. Make sure to hook up the middle pin of the potentiometer. I forgot to do so in this clip, and I apologize. And just like that, our circuit's all done. So now I'll hand it over to Xavier to explain the circuit's code. See you all in a minute.
All right, everyone. Here we are, the last circuit in project 1. Good job. You guys are doing great. You're getting farther. This is going to be awesome. Okay. So we are on again, the fourth project, the last project in project 1. So circuit 1D RGB night light. Okay, first off, let's just get this out the way now. I do not sleep with a night light. I don't. I don't. I sleep with the TV on. I like to I like to chill. I like to fall asleep to the soothing sounds of SpongeBob, Jimmy Neutron, Danny Phantom, some OG cartoons. It's just, why am I defending myself? I don't need to defend myself. Y'all just don't know. So the point of this circuit is supposed to turn an RGB LED on or off based on the light level read by a photoresistor, and then change colors by changing the potentiometer. Okay, so let's just dive straight in. So we have our defined variables all here. So integer, photoresistor, potentiometer, threshold, red pin, green pin, and blue pin. And we have all the pins and values they're equal to. Okay, so that's great. You can see it in the comments here for each one. And that's great. So let's just go straight into void setup. And then, yep, we have our serial connection. And here we have the pin mode for red, green, and blue pins, and they're all set to output. Okay, so now let's get into the loop. So let's see, we have our photoresistor and potentiometer here, and let's see, analog read the values of both. Okay, and then serial.print for the photoresistor value, and then the photoresistor value. Print the photoresistor value to the serial monitor. Okay, looking good so far. Okay, here we are right here to the if statements. So if it's dark, the photoresistor value is below the threshold, turn the LED on. These nested if statements check for a variety of ranges and call functions based on the correct photoresistor value. These functions are found at the bottom of the sketch. Okay, so they could have done a multi-line comment here, but really it's a matter of personal preference. Honestly, I might have done it this way, but more because these are quick, short comments rather than complex, descriptive comments. The code is always up to the programmer's preference, so, whatever works to get things running. I also want to turn some attention on these nested if statements. So basically, a nested if statement is an if statement inside an if statement. So what we have here is if photoresistor is greater than threshold, then it'll do whatever is in these brackets, which are other if statements. So the nested if statement, the if statement within the if statement, we can look at right here is if photoresistor is less than 0. Also, there's a logical operator here. This is a new one for you guys. This one is and potentiometer, and here's a new one for you. So potentiometer is less than 0, and potentiometer is greater than or equal to 150, then the function red activates. So yep, we're introduced to and we're introduced to greater than or equal to. So there's also a less than or equal to sign, and when you just want equal to, you put in 2 equal signs, and that's just for reference. So then Yeah, so the point of nested if statements is if one value is satisfied and if the other value is satisfied, then something happens. And then, of course, the else right here is what happens if the parent if doesn't happen. So we can move on here because we can see all the colors red, orange, yellow, green, cyan, or however y'all want to pronounce that, blue, magenta, like Blue's Clues. I'm funny. Anyhow, so now we're at this little junction. So pretty much, we see right here void, and then red, and then we see some code going on here. So you may recognize this from void setup and void loop. So what the programmer's trying to do here is basically define a function. So then, what is a function? A function is pretty much something it's something you use when you want to use many lines of code like over and over and over again. So then the code inside these curly brackets executes whenever the function is called in the main program. And that way you can save yourself a lot of time not writing a lot of code, but just instead using a function to automate it. So we actually saw the function up here, red, because this nested if statement is calling it. So if potentiometer, yada yada yada, is it does its thing, then this function red is called and it sets the LED pins to make the LED red. And then we have the same for orange and yellow and green, cyan, whatever, blue, magenta, and then we do have one for turn off. So that way it sets all 3 LED pins to 0 or off. And of course, just to make sure you guys understand, to call a function, you don't need to put the void anywhere else. You only put the void when you're defining the function. When you just want to call it, it's just as simple as putting the name of the function. If it's already defined somewhere in here, then you should be perfectly fine. And that is pretty much everything. Again, good job, guys. You are doing absolutely wonderful. And can't wait for you guys to start Project 2.
Okay, thank you, Xavier. Now that the code is all uploaded, if you turn off the lights, you should see the LED turn on like in Circuit 1C. However, if you turn the potentiometer, you'll see that the color changes. It is using the analog values from the potentiometer to decide which color or colors should be turned on. Alrighty, well that's all for this circuit. Click on to the next video whenever you're ready, and thank you so much for watching. Have a good rest of your day.